Hello fellas. So in this lesson, let's take a look at the driver for the LCD display. What I'm going to do is I'm going to create a new interface and a new implementation file. I'll come over here to my source group, right click, add new item, and this first one is a .h file, and I'll call it the GLCD ST7735. Then I'll add it. Then I'll create a .c file as well. Right click. Okay, let's just add the .h file first. Double click here, come here, select all files, and it exists on the disk. Right, so I close here like this, click here to close. Then I'll come over here, right click, add new item, this one here, and it's the same name. So then we'll populate this file, and then we rebuild, then eventually we test the modules one after the other, and then we move on to take a look at the other aspect of the real-time operating system, which is why we are really here. So yeah, let's continue. So this implementation file is very straightforward as well. This interface file, sorry, we start with the standard definition if and def, and then we conclude with end if, and then we put a content in between here like this, and what we want is to include stdint .h, and we need an API to initialize the LCD module. We will need another API to initialize the SPI module of the microcontroller board, and I'm going to bring both of those prototypes at once like this. Right, so this one initializes the GPIO for the ST7735 LCD module, and we know what the GPIO for this is. It's this, RSDC and CS, so we're going to use the GPIO init function to do that job, and we're going to use the SPI init function, which we'll write to initialize the serial clock and the serial data lines. So let's move on. Oh yeah, I put this in the .c file instead, so I'm just going to cut and paste it into the .h file. Right, and I'm going to save all my files by clicking here. Next, I'm just going to define some pins, and I'll create symbolic names for certain functions. I'm going to declare LCD reset 1 to set the reset pin high at once, and then LCD reset 0 to set the reset pin low, so that whenever we want to set it low, instead of typing the full instruction, instead of typing HOR GPIO right pin, GPIO B pin 4 pin set, we can just say LCD reset 1 and then it sets a high. It would execute this instruction just by using the symbolic name. So I'm going to do the same to set a reset pin low. And this one here I'm going to name reset 0. And I'm going to do what I just did for the DC and then the CS pins. And the DC, we're going to need to set a DC high and then DC low during our initialization of the LCD module. And I'm going to finally do the same for the CS by using the symbolic names, just like this. And now I'm going to provide an API to send commands to the LCD module, and then another one to send data. So I'm going to bring them both at once. During initialization, we will need to send specific commands and data to the LCD, and we can just use these functions, which we shall write. We will provide an API for sending 16-bit data. We shall call that send 16 data. I'll just put that here as well. And then we will have SPI2 init, and we shall use this function to do the complete initialization just once rather than step by step. We shall keep everything inside this function so that when we just call this function, all initialization is done. Apart from that, we need quite a number of defined statements. we need a statement that would define the dimensions of the LCD screen. So I'll just bring this one here. This one defines the width and the height of the particular LCD. After that, we will have to define some colors and some particular registers of the LCD. I'll bring the color definitions, and this one here defines a number of colors, and we define a number of registers. We give their addresses symbolic names, and we can define our font as well. I have this. The font is generated. The font array can be defined in the same file. Just put this here like this. So all this takes care of the hardware, data transfer, communication, and all of that stuff. Now we need the set of API to perform the graphics manipulations like drawing lines and coloring the screen, etc. So I'm going to bring all of them at once. We need an API to set a cursor. We need another one to draw horizontal lines, one for drawing the axes, another one for drawing vertical lines, for plotting data, and for incrementing the plot, etc. Let's see them. I'll just bring them all at once. And if you require explanation to any of them, do leave your questions below or send me a message. So we use this like this. It's very simple. And we can have defined statements actually. We can define our background color using any of the colors. So I could actually come here and add a bit more to what we have here. I'll just say define BG color, and we could use black as our default color, so that whenever we say BG color, the color black is chosen. And we can define our axis color. Remember, we're going to be plotting data. We may need to have some X and Y axis, so I'll define axis color, and I could use orange because we already defined the colors. I'll keep this aligned here like this. It looks unaligned because this is misspelled. Yeah, so these are the APIs. So in the next lesson, we shall look at implementing the APIs here. So I'll see you in the next lesson.